So far, we have been introduced to the dot product, and pretty much the only thing we've done is we've been told how to find the dot product of two vectors. Now I want to explore that dot product a little more, and I want to start by considering two vectors. We have the v right here, this red vector, and it's in trig form. So its magnitude is right here, and the direction angle is alpha. That's the angle that of rotation here. So there's the angle alpha. Now we've got another vector w, which is right here, and it has a direction angle of beta. Okay. Now, what I want to do is I want to come up with a method for finding the angle between these two vectors. Now, this angle is, we're going to say, this is the angle between 0 and 180, or between 0 and pi. Okay? So, theta is between 0 and pi. Now, let's look at, let's just remember something real quick. Remember that back when we were studying identities, we discovered that the difference angle for cosine is this. Cosine of alpha minus beta is equal to this thing right here, this expression. This was one of our identities that we studied. Now also take note of something here, that this angle theta, really if you take this big angle alpha and subtract off the small angle beta, you get theta. So theta is really alpha minus beta. Okay, now let's find the dot product of v and w, v dot w. Now, I have taken the liberty of just factoring out the product of the magnitudes here. I did that in advance, but notice what the dot product would be. It'd be cosine alpha times cosine beta, there that is, plus sine alpha sine beta. That's what that is. Okay? And like I say, I just didn't distribute the magnitudes through. I just kept those out. Now, notice this. These two things are the same. In other words, cosine alpha cosine beta plus sine alpha sine beta, I can replace that with alpha minus beta. And notice this, that alpha minus beta is just equal to theta. Well, if that's the case, then I can replace alpha minus beta with theta. And I have v dot w equals the product of the magnitudes times cosine theta. And if I divide by the product of the magnitudes, I get a formula for theta. Because I'm told that the cosine of the angle between the two vectors is equal to the dot product over a product of the magnitude. The product of the magnitude. So, what we have here is a formula that we can use to find the angle between two vectors. Now let's look at an example. Let's suppose we have two vectors. So I need to find the dot product. And the dot product of these two, you see I've got 1/2 times square root of 3, that's right here. Square root of 3 over 2 times 1, that's right here. The dot product is square root of 3. See? I got 1/2 of a square root of 3 here, another 1/2 here, that makes 1 square root of 3. Then we look at the magnitudes, because I've got to divide by the product of the magnitudes. This first one has a magnitude of 1. The second one has a magnitude of 2, so the product of those magnitudes is 2. And what we get is the dot product, square root of 3, over the product of the magnitudes 2. Well, if you look on the unit circle and say, well, where does cosine theta equal the square root of 3 over 2? You know, between 0 and pi. Well, that happens at pi over 6. So the angle between those two lovely vectors is pi over 6. Now let's look at another example. Let's suppose we have the v and the w. Now, here's a v vector, here's a w vector. Now, let's take note of something here. Notice the slope on this vector. You go over 1 and up 2. This slope right here of v is 2. The slope on the w down here, you go down 1 and over 2, right? This is negative 1/2. So we have a slope of 2 on the v and negative 1/2 on the w. Those are negative reciprocals. So if these were lines, you would say, well, they're perpendicular. because the slopes are negative reciprocals. So here's what we have. We have v equals 1 comma 2, w equals 2 comma negative 1, right? See? 2, negative 1, 1, 2, like that. Now let's get the dot product. The dot product, we have 2, 1 times 2, plus 2 times negative 1. 0. Notice, for these perpendicular vectors, let's call them orthogonal. When we're talking about vectors, a lot of times, instead of saying perpendicular, we'll say orthogonal. These orthogonal vectors have a dot product of 0. Now, if we put that into our formula and have the dot product over the product of the magnitudes, what we get is cosine theta equals 0. Well, cosine theta equals 0, that means that theta equals pi over 2. So here's what we note here. Whenever you have a dot product of 0, you know that your vectors are orthogonal. That's a very important concept. So you want to test to see if vectors are orthogonal? Find the dot product. If the dot product is 0, then yes, your vectors are orthogonal. Okay?